Sleepy MCToon, tend to your flock. Hey, Sleepy MCToon, stuff the money in a sock. Preach like Sleepy Tune, pass around the money cup. Your flock is your silver spoon, they are sheep out of luck. Only Toonie had a globe, me I see la told, and on that globe he had some sheep. Here I me I show with the flat map here. A cat nap there, here a nap, there a map, everywhere a super chat.
Okay, so the height of the cloud is 1
I'm
mile.
not driving a perfect straight line either.
Okay, so you're saying it should have been 57 miles away, but you only drove 14. Is that what you're saying? Okay, so how did you get the 57? I want to walk through how you got 57.
Dude, why are you asking me that? I posted it for you.
So anybody who's ever used the triangle calculator knows he's playing games. So for angle A, which is observer angle, I put 1 degree, which he quoted. And then for side A, the opposite side, the height of the cloud, I put 1 mile. And you get 57 for B, the baseline, the adjacent. So he's just playing games, dodging the point. So if the bottom of a cloud is 1 mile high and it's way off at the horizon, just 1 degree above the horizon, like 2 sun widths, then if you took off driving in a straight line toward it, it should be 57 miles before you're underneath it, on a globe or a flat plane. So, and what MCToon was trying to avoid is discussing my video where I drove towards said cloud and I was underneath it in 14 miles, not 57. And I know it's not exact. I know clouds move, and I know we don't have the exact height to them, but 14 and 57 is a huge difference. So even if the cloud was 4 sun widths above the horizon, that's still twice as far I should have had to have drove. So I tried to be conservative with the estimates, but the point here is curved visual space, or like the dome vision we have. When we walk outside on one little flat patch of ground, the ground shouldn't dictate what we see above us, because we're standing on one little flat patch of ground, but we see the clouds kind of domed on a lot of days. We see jet trails domed. The stars look like they're domed. So if we get together and do some more of these tests, we can narrow it down and prove that it's our vision. At the very least, we can get them to quit strawmanning us and trying to hold us to strict trigonometry. This is massively important, because this would be an easy way to prove that they can't just hold us to strict geometry. They try and just take away any and all of reality and any other variables and pin our model down to just pure geometry, which is horseshit. No matter what we show them, they sound like broken records. So we need to investigate this.
Opposite over adjacent, man. You got to get the sign of 1 degree. Hold on a second, man. I'll post that too. Y'all want me to show my work? Hold on. For fuck's sake. Basically arguing with the triangle calculator, trying to dodge the point, because he knows it's right. And now I got to find a pencil and a piece of paper and shit to write it down. I use the triangle calculator. Okay?
MCToon was trying to claim that we should see Polaris from South America on a flat Earth. And I'm trying to explain to him that the trigonometry doesn't work in reality like he thinks it does on things up high. And I used an example of when I picked a cloud that was just barely above the horizon, a couple sun widths, and I drove towards it, and the trig says that the distance for me to get underneath it should have been 57 or 114 miles, depending on whether it was 1 or 2 degrees above the horizon. When I watched the video again, I realized that he was trying to get me to walk him through it like I didn't understand how to solve a triangle, which I didn't get that at the time. I thought he was just diverting, which he was diverting. But anyway, so here, Toon, I'm going to show you how to solve a triangle so you can be wrong on every single count and every point you made that entire night. So let's say that the cloud is 2 kilometers above the Earth's surface, and we have a 1 degree angle, viewing angle, so it's 1 degree above the horizon. On a flat Earth, it should be about 114 kilometers away. On a globe, it's damn near the same. It's barely any difference because we're not talking about stars. We're just talking about a cloud. So a tangent on a globe would put you right up underneath it, but you'd be angled forward just a little over 1 degree, which is going to make virtually no difference in the distance to the cloud. And if you followed the Earth curve, it would just be higher up. So it's almost the same on a flat Earth and a globe Earth. Now, I usually use the triangle calculator for shit like this, but that doesn't mean I can't solve it. Because when you're talking about the tangent function, which tangent is opposite over adjacent, okay, we got the opposite. So all we need is the adjacent. And so to get the tangent, you just multiply the angle times pi divided by 180. If it's 2 degrees, it's 2 times pi divided by 180, and so on, which I'll show on the calculator in a minute. So now that I've got the tangent, I just divide 2 by 0.0174, and that's your adjacent. But so this is what we use. SOHCAHTOA, sine equals opposite over hypotenuse, meaning opposite divided by hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. So the one way to get the tangent function, in fact, I'll show you that in the calculator. Okay, here's how I get my tangent. I mean, usually I just go to my calculator, even on my phone, and hit tan 1 degree. If it's a 1 degree theta or observer angle, theta is the observer angle. So but another way to do it is 1 times pi divided by 180. Okay, and it's 0.017. So for 2 degrees, your tangent is 2 degrees times pi divided by 180. So it's 0.034. And so 3 degrees, your tangent at 3 degrees is 0.052. 4 degrees is 0.069. And 5 degrees is 0.087. And so on. That's probably the easiest way to do it. But here, so let's see what we have now. So what we have here is a 1 degree observer angle, or theta. Got a 1 degree theta, and we got a 2 kilometer cloud, we'll call it. So the hypotenuse, remember the hypotenuse is, if this is the tangent, then this is the radius. So this is the hypotenuse and the radius. So if this is 1 degree of the circle and it's 2 kilometers, then 360 degrees is 720 kilometers. So we'll write down 720 kilometers, and then we are going to divide that. So 2 pi r, so that's the whole circumference of the circle, 720 kilometers. So to get the circumference, it's 2 pi r. So now we just divide it by 2 pi, which is 6.28, which I'll do that in the calculator also. Okay, now I said I was going to do this on the calculator. So we got 720 kilometers is the whole circle circumference. So to get the radius, or the hypotenuse, then we just divide that by 2 pi, or 6.28. So divided by 6.28. So 114.64 kilometers is the hypotenuse. So what all do we know here? So the easiest way to do this is going to be to just take the 0.017 and divide that. I mean, it's going to be 2 divided by 0.017. But what are some other things we know? So we know if that's 1 degree and this is 90 degrees, then we know there's 180 degrees in a triangle. So we know that this angle is 89 degrees. So that's more information we got. And we could get the adjacent, or the baseline, by dividing 2 kilometers by 0.0174. You can go into the decimals, but it depends on how accurate you're trying to be. Another way to do it is you can use Pythagorean theorem. You could say a squared plus b squared equals c squared. So as long as we have the opposite and one other side, we can square them each, add them together, and the square root of that number will be the missing side. So there's a couple different ways to go about solving these triangles. If you're debating somebody like MCToon, be prepared for questions like that. So if he catches you off guard, then he can divert from the problem you presented. And there's the Pythagorean theorem right there. So if you want to use that method to get the radius. So there, I'm showing my work, Toon. You happy now, bud?
Sleepy MCToon, tend to your flock. Hey, Sleepy MCToon, stuff the money in a sock. Preach like Sleepy Toon, pass around the money cup. Your flock is your silver spoon. They are sheep out of luck. Only Toonie had a globe. Me, I see la told, and on that globe he had some sheep. Here I me, I show with the flat map here. A cat nap there, here a nap, there a map, everywhere a super chat. Sleepy MCToon, tuck them into sleep. Your sleepy sheep do love the lies you preach. Enjoy all the bread, your flock's fast asleep. Your sheep are brain dead, no cash cows, it's cash sheep. Sleepy MCToon, tuck them into sleep. Your sleepy sheep do love the lies you preach. Enjoy all the bread, your flock's fast asleep. Your sheep are brain dead, no cash cows, it's cash sheep. Sleepy MCToon, tend to your flock. Hey, Sleepy MCToon, stuff the money in a sock. Preach like Sleepy Toon, pass around the money cup. Your flock is your silver spoon. They are sheep out of luck. Out of luck. Only Toonie had a globe. Me, I see la told, and on that globe he had some sheep. Here I me, I show with a flat map here. A cat nap there, here a nap, there a map, everywhere a super chat. Wake up silly Toon, wakey wakey for good. Dream of Saturn's moons, pretend they're understood. It's Tuesday Toon, preach, pour it on thick Toon. Appease your paying sheep while your horse shit's in bloom. In Sleepy Toon the flock trusts, spread them like sheep. In Sleepy Toon they trust, I promise moon mission sheep. Trust shepherd Sleepy Toon, your shepherd will provide fake missions to the moon. Fill your mind with globe lies. Oh luck, oh, oh luck, oh, oh luck, oh. Sleepy MCToon never tires, never tired of being wrong. Preach the sheep he inspires. Your shepherd is never wrong. Wake it up, wakey, stay woke. Appease the pain sheep Toon, laughing at truth like a joke. Promise missions to the moon. Sleepy MCToon, tend to your flock. Hey, Sleepy MCToon, stuff the money in a sock. Preach like Sleepy Toon, pass around the money cup. Your flock is your silver spoon. They are sheep out of luck. Sleepy MCToon, tuck them into sleep. Your flock pays you, no cash cow, it's cash sheep. Nap time is over, wake, hold out your money cup. Your sheep don't know you're fake, they are sheep out of luck. The flock trusts, spread them lies cheap. In Sleepy Toon they trust, I promise moon mission sheep. Trust shepherd Sleepy Toon.